Very good morning to all of you. I once again welcome you all to this current lecture. In the last lecture, we discussed about what is meant by the R and S configuration, what is the meaning of R and S configuration, how this configuration can be assigned around the chiral center. So all these introductory part we completed in a last lecture. Now we know very well that in order to assign either R and S configuration around the chiral center, we have to first of all assign the priorities around the chiral center, and for this purpose we have to use some rules, and that rules are called as the sequence rules. So these sequence rules are very much important as far as the assignment of this R and S configuration around the chiral center is to be considered. So in a current lecture we are going to study what are the different sequence rules which are to be useful for assigning the priorities around the chiral center. So that rules we have to study one by one in this current lecture. So as far as these sequence rules are to be considered, three important sequence rules are generally followed in order to assign the priorities around these particular groups or atoms around the chiral center. So as far as this first sequence rule is to be considered, the first sequence rule is called as the atomic numbers. The first sequence rule is called as the atomic numbers. Now, as far as this atomic number is to be considered, so whenever the four different atoms or groups attach to the particular chiral center, so first of all, in order to assign the priority, we have to take into consideration their atomic numbers. So as far as these atomic numbers are to be considered, we have to assign the priorities depending upon the increasing atomic number. Suppose those atoms or groups in which that atoms which having the highest atomic number can assign the highest priority as compared to the lower atomic numbers atoms or groups. Suppose if we consider here the first simple chiral center, suppose this is a carbon is to be considered to be as a chiral center. To this carbon atom, suppose four different atoms are to be attached. Suppose this is oxygen, this OH suppose, and this is, suppose it is the deuterium. Suppose this is one chiral center to which four different atoms or groups to be attached. First is called as a hydrogen, second is called as a chlorine, third is called as OH, and fourth is called as a deuterium. Now, if we want to assign the priorities to these four different atoms or groups, at that time we have to take into consideration sequence number or sequence rule number first, that is atomic numbers. We have to take into consideration their atomic numbers. Now, if we consider atomic numbers of these four different atoms, what happens? The atomic number of chlorine is more than that of the atomic number of oxygen, and this atomic number of oxygen is greater than that of the hydrogen and deuterium. So we have to just assign these priorities as this chlorine, due to more atomic number, has the highest priority as compared to this OH. This OH has the more priority as compared to this particular hydrogen and deuterium. Now what happens? In this case, this hydrogen and deuterium are called as isotopes of each other. These isotopes having the same atomic number. So at this situation, when two atoms having the same atomic number but different mass number, so at that situation, we have to assign the highest priority to those atoms which having the more mass number. So as compared to hydrogen, deuterium has the more mass number. That's why this deuterium has the more priority as compared to this particular hydrogen atom. So according to sequence rule number first, by considering their atomic numbers, this is the sequence rules for these four different atoms or groups. So chlorine has the highest priority, that's how we can consider it as a first priority group. Then this OH, so it is a second priority group. After that, this deuterium has the third priority and this hydrogen has the fourth priority. So this is a simple sequence rule number first. We have to take into consideration the respective atomic numbers of the particular atoms or groups surrounding this particular chiral center, and if two atoms having the same atomic number or if the two atoms are isotopes of each other, at that situation we have to take into consideration their mass number. Okay, so this is the first sequence rule, that is called as the atomic numbers. The next simple rule we have to take into consideration, that is the next atoms. We have to take into consideration this next sequence rule, next atoms. Now, what is the meaning of this particular next atoms? So that we have to study now. So for this purpose, I again take here the next simple example of chiral center. Suppose this carbon is to be considered as the chiral center. Suppose it has four different groups. Suppose this is a hydrogen CH3, it is the CH2, CH3, and this is supposed to be called as the iodine, suppose. So this is a one simple example of a chiral center, suppose here. Now we are interested to study the sequence rule number second, that is we have to take into consideration the next atoms. Now what is the meaning of this particular next atoms? Now if we look towards the four different atoms or groups which are to be attached to this particular chiral center, so first atom is a hydrogen, second is the iodine, but this third and fourth are called as the groups. One is a methyl group, second is called as the ethyl group. Now in this situation what happens, if two similar groups are to be there in which the starting atoms are to be similar, it means in this group, methyl group, this carbon is directly attached to this chiral center, while in this ethyl group again this carbon is directly attached to this particular chiral center or chiral carbon atom. So at that situation what happens, we have to compare that group by atom by atom. If the first initial atom is similar, we have to check the next atoms which are attached to the this directly attached atom to the chiral center. Suppose in this case the first atom is a carbon, in this case also the first atom is a carbon. Now both are similar, so we cannot assign the priorities among this methyl and ethyl group. So at that situation we have to take into consideration the next atoms. Suppose if we consider this methyl group, it is a carbon to which three hydrogens are to be attached. So this is a methyl group. If we consider this ethyl group, so what happens in this ethyl group? This is a carbon, to this carbon two hydrogen atoms and one methyl group is attached. So this is a simple method of writing this particular methyl as well as the ethyl. Now our question is that which group has the highest priority. So for this purpose we compare these groups by atom, since this first carbon and this first carbon having the similar atomic number, so we are not in a position to assign either priority, highest priority among these two groups. So for this purpose what we have to do, we have to take into consideration the next atoms. So next to this carbon what happens, 1, 2 and 3 hydrogen atoms are attached to this particular carbon. At the same time to this carbon atom what happens, first and second two hydrogen atoms are attached, at the same time one methyl group is attached. So if we compare 3 hydrogen atoms towards or with that of 2 hydrogen and 1 methyl group, it is very clear to us that as compared to 3 hydrogens, 2 hydrogen and 1 methyl group get the highest priority as compared to this particular methyl group, and that's why this ethyl group has the highest priority as compared to methyl group. So now if we assign all the priorities among these four different atoms or groups, then what happens, iodine has the highest atomic number, so it has the priority number first. Next to that, and this is carbon, this is carbon, and just we assign here as compared to methyl, ethyl group has the more priority, so it is a has the second priority, methyl group has the third priority, and this hydrogen has the fourth priority. So this is a simple sequence rule number second, next atoms, means two similar atoms are directly attached to the chiral center. At that time we have to check the priority by considering, by comparing the atomic numbers of the next atoms present in a particular group. So this is called as the second sequence rules, called as the next atoms. Now after considering these two simple sequence rules, we have to take into consideration the next atom, that is groups containing double or triple bonds. Groups containing double or triple bonds. So this is a next important sequence rules for assigning the particular priority among the groups. Now this is called as the groups containing either double or triple bonds. So for clarification of this third sequence, rule, we have to take into consideration one simple example of the compound. Suppose the first example is we consider here chiral center, this centrally situated carbon to which four different atoms or groups is attached. It is the C triple bond CH, it is the C double bond CH2, and this is suppose H is there. Suppose this is the one chiral center, centrally situated carbon to which this oxygen C triple bond C is there, C double bond CH2 is there, and first is a H is there. Now, in order to study this particular third sequence rules, suppose I consider here again simple example. I consider here a simple example. Suppose if I consider such a type of the chiral center, carbon, this is a hydrogen, this is a C double bond, sorry, it is a CH double bond CH2, it is OH suppose, and this is the C triple bond CH. So this is a one chiral center, a chiral molecule we have to consider here. First group attached is a hydrogen, second is a CH double bond CH2, third is a OH, and fourth is called as a C triple bond CH. Now, as far as this third sequence rule is to be considered, what we have to take into consideration, the atoms in these double or triple bonds is to be considered. Suppose if in our molecule or in a particular chiral center, if C double bond C is to be present, if C double bond C is to be present, then what happens? This C double bond C is to be considered as, right here, if this C double bond C is to be present, then what we have to take into consideration? If suppose a group like C double bond C is to be present, then what happens? This group is nothing but, when C double bond C is nothing but, it is equivalent to carbon, single bond carbon, single bond carbon. Means one C double bond C, this carbon is equivalent to two carbon atoms. So this is a C double bond C is there. If suppose group like C triple bond C is there, if a group containing C triple bond C, at that time this is equivalent to carbon, single bond carbon, single bond carbon, again single bond carbon. So this C triple bond C is nothing but the equivalent to three carbon atoms. If the groups like suppose C double bond O is there, if a group like C double bond O is there, at that time what happens? This C double bond O is nothing but it is equivalent to carbon, single bond oxygen, single bond oxygen. So two oxygen atoms, it is equivalent to this particular C double bond O, and at the same time if a group like C triple bond N is there, suppose C triple bond N, then what happens? This C triple bond N is nothing but the equivalent to three more nitrogen atoms. So this is nothing but the sequence rule number third, that is the groups containing either double or triple bond. So if double bond is there, that is nothing but the, it is equivalent to the two more atoms. If a triple bond is there, it is equivalent to the three more atoms. It may be the carbon or it may be the nitrogen. So this is the third important sequence rules. By considering these third sequence rules, we have to assign the priorities to this particular chiral center in which one double bond is there, one triple bond is there, one OH and one hydrogen is there. So again we have to follow the sequence rule number first. We have to consider atomic numbers of the directly attached atom toward this particular chiral center. So among these four different atoms, this oxygen is directly attached to this particular carbon. So this oxygen has the first priority. So we can write here priority number first to this OH group. After that, in comparison to this double bond and triple bond, just we studied here, double bond is nothing but the equivalent to the two carbon atoms, while the triple bond is nothing but the equivalent to the three carbon atoms. So by considering sequence rule number third, we can assign the second priority to this triple bond, third priority to this particular double bond, and fourth priority to this particular hydrogen. So by assigning these, we get here the four different sequence for four different atoms or groups. This OH has the highest priority, then this C triple bond CH has the second priority, then this C double bond CH2, and at the last this hydrogen get the lowest priority. So these are the three different type of the important sequence rules for assigning the priorities for the atoms or groups surrounding the particular chiral center. And by using these particular priorities, it is very easy to us to assign either R or S configuration to the particular chiral center. So in this current lecture, we discuss here the three important sequence rules for assigning this R and S configuration. The first important sequence rule is that in order to assign the priorities for the atoms or groups, you must take into consideration their atomic numbers. Those groups or atoms which having the more atomic number get the highest priority as compared to the lower atomic number groups or atoms. If suppose two atoms or if the two isotopes is there, at that time you have to take into consideration their respective mass numbers. The second important sequence rule is that we have to consider the next atoms. Suppose if in a particular group two initial atoms are to be similar, at that time we have to carry out our comparison to the next atoms. This is the sequence rule number second. And the last important rule, that is groups containing double and triple bonds, which already we discuss here. So if a double or triple bond is there, that double or triple bond is nothing but the equivalent of the particular atoms. If double bond is there, it is two more equivalent we have to add here. If triple bond is there, we have to add two more equivalents of the particular atoms. And by considering all these sequence rules, we can assign the priority from 1, 2, 3 up to the 4. And by considering all these priorities, we have to assign the actual configuration for the given chiral center. So in this current lecture, we discuss this particular important sequence rules. Now in the next lecture, we have to study the actual assignment of this R and S configuration for the different type of the chiral centers. So with this, I stop here. Thank you. Thank you so much.